I want to take a look at section 1.3 of our supplement, and this section talks about concave up and concave down. When we are doing concave up on this, I will do that in blue, and then when we are doing concave down, I will do that in green on these pictures here. So what I want you to think of for concave up is I want you to think of a cereal bowl. And a cereal bowl is normally somewhat round, and when it's sitting on the table and it's holding your cereal in, that's the shape of concave up. So if we look at graph A, notice that from about here all the way until about here, you have a cereal bowl that could hold cereal in. So the concave up section is going to be from this -4 all the way over to 0. So if we wanted to do the concave up, I'll just do up and a colon for concave up. That would be from -4 to 0 using the x coordinates, -4 and 0, in your interval there. Now for concave down, think of going to the kitchen sink and you decide to dump your cereal bowl out and empty it and clean it. That's your concave down. So if you've now turned your cereal bowl over, you now have a shape that looks like this section. Notice this first graph A has a section there, and it also has a section here. And notice at the end of each of those sections you have an open dot here and an open dot here. That means in our interval notation we're not going to include that point, and we'll have a round bracket at the -8. So the first concave down section goes from -8 up here to -4. The second concave up section starts right here where x is 0 and goes up until x is 4. So for the concave down section, and I think I said concave up accidentally a minute ago, but I meant concave down. For this concave down section, we'll do down and a colon. That's from -8 on your x-axis up until -4. Now, since there is a gap between that section and the next section, I'm going to erase this so I have a little more room, then you want to have a union symbol in your interval notation. So we'll have a union here, and the new concave down section here starts at 0 and ends at 4. And since there's that gap where we're concave up there in the middle, that's why we use the union symbol in between those two intervals. Now, that's for that graph. When you get to calculus, you'll learn about the points where they switch from concave up and down, and those are called inflection points. But for right now, we're just looking for concave up and concave down. On the next one, notice on B, we have arrows on the end. Since we have arrows on the end, we're going to assume this shape continues forever when we do our concave up and concave down. Now, you can have, on the first one, we had full cereal bowls that we could see and visualize the cereal staying in the bowl or not staying in the bowl. On this second one, there's actually a half a bowl. Notice that this, if I were to continue it on, would be concave down. You'd have a cereal bowl dumping the cereal out, but it kind of stops right here. And then after that, it continues on in a shape to about here that would be concave up. It would be holding your cereal in if we continued it on like that. So we have half bowls here. So, and then after we switch right about there, and we're just again going to estimate those spots where they change for right now, then we dump our cereal out again. So the green areas are the concave down, and the blue area is where it's concave up, even though we do have partial cereal bowls. So let's do the down first, because I've got green out. The first down, since we have the arrow here, that's coming up from -infinity way out here until we get to -2 here. So that's from -infinity. Actually, I don't have enough room there. I'll put it right below. from negative infinity to negative 2. But then notice there's blue, which is concave up. So there's a gap, so I'm going to do my union symbol. And then at about 0.5 it starts, and then it continues on and it goes to infinity again because the arrow. So right here, we start being concave down again, and then that continues out into infinity. So that would be from 0.5 to infinity. So that's our concave down there. Now on this one, we only have a partial bowl for concave up, but we still do have some curve that's curving to open upwards. And so this section here is concave up, and that's from negative 2 up to 0.5. So we do have a section, even though it's a partial cereal bowl, from negative 2 to 0.5 that is concave up. Now, C is tricky. Notice that there is no curve really in it. Since there's no real curve in this and everything is straight, you want to think of this as if this was a cereal bowl right here, this cereal bowl could not sit on the table. This point here would make it tip over. When it's straight like that and you don't really have any kind of curve like we had on the other ones, you're actually neither concave up or down. So this one here would be neither concave up or down anywhere. We do have a decreasing section in this where it's going down here and an increasing section right here, but both of those are straight and they don't have the curve we had in the other ones. So this is neither concave up or down anywhere on there. And then D is probably the easiest of all of these. I'll do concave up first. Notice we have an arrow here, so it's going to go on forever. And we have a full cereal bowl until we're about right here, where X is 1. So that's all concave up. So out here from negative infinity up until the 1 here. So the concave up would be negative infinity to 1. And then the concave down, where you dump your cereal out, starts here at 1 and continues on. And you have an arrow on that, so it goes forever. So from negative 1 up to infinity, positive 1 up into infinity, that's where it's concave down. And that's section 1.3 of your supplement.